we're going to do a slightly more difficult kind of bond energy calculation now. And in this one, they tell us what the energy released is, the energy change. And they can see here it's minus 80 for that reaction, it's minus 85 kilojoules. And that means it's exothermic. And we're given our bond energy values for carbon-carbon, carbon-carbon double bond, carbon-hydrogen, but we're not given the value of the carbon-bromine bond, and that's what we've got to find out. Also, we need which I should have written in there. They do tell us the value of the bromine-bromine bond. That has a value of, where are we? Pretty weak one, it's 123. Okay. So what we've got to find out is the strength of the carbon-bromine bond. That's what we've got to find out. Right, so we do the same method as we've used before. So what we're going to do is we've got a box around those. We're going to break those bonds up. We're going to break all of those. That's going to be endothermic. So breaking. So going to be positive values. I'm going to break it into separate atoms, 2 carbon atoms, 4 hydrogen atoms, and we've got 2 bromine atoms as well. And then we're going to build those atoms up to form the new molecules here. New molecule, which is that one there. This is actually the test for a double bond, isn't it? Because of this stuff here is bromine, Br2, which is red, and a double bond will decolorize bromine water. Okay, so anyway, so we're going to get energy out there, so that's exothermic, so these are all going to be negative values, so we're making bonds. Right, what are we breaking here? So we're breaking a carbon-carbon bond, which is 612. We're breaking 4 carbon-hydrogen bonds, and they are 413. And we're breaking 1 bromine-bromine bond, which is a pretty weak one because bromine is a big atom. That's 123. Okay, if we add all that up together, we get plus, because it's energy out, 2,387 kilojoules. Now, making, on this side now, right, we're going to make a carbon-carbon single bond, so that's 347. We're going to make 4 carbon-hydrogen bonds, each one of those is 413. And we are going to make 2 carbon-bromine bonds, and we don't know the value of those, so we're going to call that, let's say each one is X, so that's going to be 2X. So if we add all that up, what do we get? Right, so we get that's 1,000 minus 1,999, and then it's going to be minus 2x because we're forming 2 of those bonds. Okay. Now what we do know is the total energy released up here, that's got to be equal to the green number added on to that red number for making them. So let's do that. So we've got minus 85, that's the energy released. With this one, you can see it's pretty important to stick with that convention of making positive, breaking negative. Yeah, like endothermic positive, exo negative, because if you don't, it's very easy to get confused. Okay, so that's going to be equal to the green number, which is plus 2387. Ready? Minus 199 and minus 2x. So let's just simplify that a little bit. We're going to get minus 85. Right, so 2387 minus 1999, that's plus 388, minus 2x. So let's take that to the other side of the equation. So you get minus 85 minus 388 is equal to minus 2x. So we get 473 minus 473 is equal to minus 2x. So 4 plus 473 is equal to 2x. X is equal to 473 over 2. That's 230, sorry, that's 236 is the bond energy for the carbon-bromine double bond. Okay, so there's our answer, and the units are kilojoules per mole. Right, if you want to do another one of those, I'm not going to go through it, but I've got this here. Can you have a look at it? So this reaction is actually, we've got butane, which is this C4H10 here, a larger hydrocarbon, a larger alkane, and we're going to break it down into an alkene, ethene, and an alkane, ethane. That's actually cracking, a cracking reaction if you've done that. It doesn't really matter what it is, but this one is an endothermic reaction. It's plus 82 kilojoules, sorry. You're only given the bond energies for the carbon-carbon single bond and the carbon-hydrogen bond. You're not given the value for the carbon-carbon double bond up here, and that's what you've got to find out. So you've got to use the same approach as you did in the previous calculation. And the right answer is 612. So give that a go.